In the early 1900s, American children had a life expectancy of only 44 years. During this part of the century, most people would spend their entire life in a 50-mile radius and might only travel 1,500 miles in their lifetime. People would awake to the sunrise or a hand-wound alarm clock. There was no radio or television for the morning news, no faucet with running water, and cooking breakfast meant using firewood to warm up the stove. What engineering advancements of the past 100 years changed our lives so significantly? On this show, we'll see the defeat of threats as vast as nationwide illness, natural disasters, and hostile enemies. We'll take a look at the significant contributions that scores of engineers have made to make life easier, safer, and better, as targeted by the American Council of Engineering Companies. We'll see ingenuity, inventions, and visionaries engineering a century of change. In the early part of the 20th century, automobiles were the first in a parade of advancements. Unfortunately, roads still used for horse traffic were not as advanced. Streets were predominantly made of dirt, brick, and even cedar blocks that made the new craze of driving a somewhat dubious endeavor.
Very few of the rural roads were paved, and when you did get a real rain, you're up to your hubcaps in mud.
In 1919, a young soldier named Dwight Eisenhower decided to join a motor convoy across the United States. An endless series of mechanical difficulties, vehicles stuck in mud, roads as slippery as ice made a lasting impression on the future president. But in 1949, a surprise announcement by Harry Truman shocked Americans. Years ahead of predictions, the Soviet Union successfully tested an atomic bomb. The government felt there was a need for the population to escape quickly in case of a nuclear attack. It also wanted to be prepared to move troops and missiles at a moment's notice. President Eisenhower worked feverishly to push through at all costs a way to provide money to create highways linking the entire country in a master plan using federal standards for conformity. But how easy would it be for engineers to create 40,000 miles of highways for an entire nation using the same federal standards through 48 states of differing terrain? Hundreds of unique engineering designs had to accommodate deserts, bodies of water, mountainous areas, and other topographical phenomena, and still achieve the same result. Considered by some as the greatest public works project in the history of the world, it also lived up to Eisenhower's hopes given in a speech prior to its inception. Together, the united forces of our communication and transportation systems are dynamic elements in the very name we bear, United States. Without them, we would be a mere alliance of many separate parts. Many engineering projects that revolutionized daily life usually ran hand in hand with advances in materials. Throughout the century, chemical engineers learned new methods to analyze and refine chemical processes to maximize their performance.
Before 1900, you pretty much had to go and get natural materials if you wanted to make something, such as stone or animal fibers. You basically had to find an animal and see which part of it you could make something out of it. And what the chemists did is really to figure out how things are put together on a molecular level, rearrange their atoms, make new molecules with new properties. And with those discoveries, the chemical engineer would come in and take that to an industrial process where they could now scale it up so that it would be something that everybody could use.
But with all the accomplishments of chemical engineers and material inventors, including the development of plastic, which now exceeds steel production by volume and mass, One particular event sums up the value of chemical engineering in the 20th century.
One event which really exemplifies what a chemical engineer can do is the story of how in World War I, Germany was cut off by the British from rubber supplies. And so what that meant was they couldn't drive their cars, the soldiers didn't have boots.
Then in the opening days of World War II, with several fascist armies threatening to take over the world, Japan rapidly captured rubber-producing lands in the Malay Peninsula and East Indies, depriving America of 90% of its natural rubber sources. Suddenly, America found itself in the same undesirable position that had confronted Germany 40 years before.
What happened was then the government and industry got together to try to put together a system to make synthetic rubber, and that's where the chemical engineers contributed. And by the end of the war, 4 years later, they were making 100 times the amount of synthetic rubber that they were making compared to the beginning of the war.
Unlike early man, who used a few tools over thousands of years as lifestyles evolved slowly, in contrast, 20th century man developed thousands of tools in a few years, and the way we live has changed proportionally. Long before anyone ever thought it was possible to go into outer space or to the moon, in 1898, a young boy reads War of the Worlds and decides to make rocketry his life's work. His name was Robert H. Goddard, and he would become the father of modern rocketry. In 1919, financing most of his experiments with his teacher's salary and a small grant from the Smithsonian Institute resulted in a small booklet less than 70 pages called A Method of Reaching Extreme Altitudes. A short sentence mentioning the possibility of sending a multi-stage rocket to the moon was included. The New York Times pounced on the sentence with an article which accused him of talking nonsense. It stated, Goddard does not know the relation of Isaac Newton's action to reaction against the vacuum of space. He seems to only lack the knowledge ladled out daily in high schools. From that point forward, Goddard kept quiet and kept going. Test after test improved Goddard's theories, and 40 years later, with the space race underway, Goddard's rocket engines formed the backbone of the space program.
Liftoff. We have a liftoff.
Rocket propulsion results in a violent explosion that produces very hot waste gases. These gases are forced at high speeds out of the rocket nozzle. A second stage explosion then fires to propel the payload to its correct orbit. From one small boy's dream, the launch and return of spacecraft from Apollo to the shuttle is one of the monumental engineering triumphs in all of human history and has spawned more than 60,000 products that have had a direct impact on the general public. On July 20th, 1969, humans watched a man walk on the moon on their television set, at the same time looking up to see the moon. After the lunar landing, the New York Times printed the following retraction 50 years later. Further investigation has confirmed the findings of Isaac Newton in the 17th century, and it is now definitely established that a rocket can function in a vacuum. The Times regrets the error. Which were contributing factors to this man with a life expectancy of only 44 years, still going strong at 97, with more to come. What changes will today's young children experience? There's no way to know for sure. But if the engineering achievements of the 20th century are any indication of the future, they could be in for quite a century.